All right, so in this video, we're going to go through sample question 59 from the Society of Actuaries, ExamP, list of sample questions. The question reads, in insurer's annual weather-related loss, X is a random variable with the following density function. We need to calculate the difference between the 30th and the 70th percentile of X. Okay, so overall, a pretty easy question. What do we need to know? All we need to know is how to go from a density function, a PDF, to a cumulative distribution function, a CDF. And we also need to just kind of know what a percentile is, right? So a percentile is, let's say we're looking for the 30th percentile. That would be a value where if we looked for the CDF up to that value, we should get out 0.3. If for the 70% percentile, if we calculated the CDF up to that value, we should get out 0.7 as our answer. A percentile you're already familiar with would be the median. That is the 50th percentile. That's something you should know how to compute at this point. Okay, so hopefully that concept's pretty simple. It's kind of a underlying, base level concept. So let's go about actually just finding the 70th and 30th percentile. So I'll start with the 70th. Okay, so I already know this should equal 0.7 when I'm going to basically compute the CDF. And I compute the CDF by integrating the PDF from 200, which is the lower bound, up to the 70th percentile. I don't know what that is, so I'll just say it's X. And I'm going to use the PDF they give me, 2.5 times 200 raised to the 2.5 over X to the 3.5. Oh, actually, I shouldn't use X, right? Because I should use a different variable than the one here. I'll use n to the 3.5. dn, right? I'm going to take the constants out. So 0.7 equals 2.5 times 200 raised to the 2.5. And integrating 200 to x. And then I'm going to change this to, instead of a 1 over n to the 3.5, I'm going to change this to n to the negative 3.5 dn, of course. I'm going to move this over to the other side. At this point, I'm just kind of describing calculus and algebra. This is actually something super easy to integrate, so I won't go so in depth into that. You'll just kind of see me work this out. So 2.5 times 200 raised to the 2.5, that's equal to integral of 200 to the x power, 200 to x of n to the negative 3.5 power dn, and then I compute this integral. Pretty easy integral to compute. It's just like the opposite of power rule, so I don't feel I need to discuss that too much. Let me just rewrite the left-hand side. And this should be 1 over 2.5, or 1 over negative 2.5, multiplied by, actually in the denominator it should be multiplied by n to the negative 2.5, which is 1 over n to the 2.5, or n to the 2.5. So the integral of this is negative 1 over 2.5 times n to the 2.5, evaluated from 200 to x. All right, now I'm going to actually open this up. So 0.7 over 2.5 times 200 raised to the 2.5. And this is something you could put into your calculator and just store as a number. And you don't have to keep rewriting it. And that's going to be equal to negative 1 over 2.5 n to the 2.5 minus a negative or plus a positive 1 over 2.5 times 200 to the 2.5. Now I add this to both sides. I'm going to subtract it to both sides. Subtract by 1 over, 2.5. That's going to cancel. I subtract it here, and that I'm actually going to begin to compute right now. Okay, so 0.7 times 2.5 to the 2.5 over 2.5 to the 200 times 2.5 minus to the 2.5. Okay. And I get a negative 0.000000. 212 equals negative 1 over 2.5 n raised to the 2.5. I'll multiply by negative 2.5 to both sides. And I'll get 0.0000053 is equal to, instead of 1 over n to the 2.5, I'll just write that as n to the negative 2.5, like that. And lastly, I'll just do a negative 2.5 root to both sides. That's something I'm able to actually do on this calculator. And I get n, or my 70th percentile, equaling 323.8095, and some more stuff. Right, so it's approximately that value. And that is the 70th percentile. So half the question's done. We still got another half to go. Now, I know it seemed long. That's partially due to me kind of explaining it out. And you might be wondering, do I have to do all of this again? You don't. The only difference between finding the 70th percentile and finding the 90th percentile, and the 30th percentile, is this 0.7 right here. Everything's going to be the same, except this 0.7 is going to be a 0.3. So I don't have to do all of this again. I can start from right here. So now this becomes a 0.3 over 2.5 times 200 to the 2.5 minus 1 over 2.5 times 200 to the 2.5 is equal to negative 1 over 2.5 n to the 2.5. Now, another way this half becomes easier is everything's already in my calculator, right? I don't need to go about trying to rework everything. I'm just going to go up and use the equations I had before. So I'll just scroll up. I'll grab the equation I had before, and instead of a 0.7, I'll replace that with a 0.3. Okay? And this will become a negative 0.000000495 is equal to a negative 1 over 2.5 n to the 2.5. Multiplied by a negative 2.5. Oop, did that wrong. By a negative 2.5. I accidentally did 0.25. Be careful with your calculator. And we get 0.00001238 is equal to n to the negative 2.5. And just as before, we're going to do a negative 2.5 root to both sides. Just one thing, because all of you should be using virtually the same calculator. We also, just by the way, find n to be 230.627 as our 30th percentile. Just a little calculator note. When you're doing a negative square root, so normally I could do like maybe a sixth root, 6, and then I do a, second, the exponent sign to get the sixth root. If I wanted to do a negative 6 and do that, the 6 goes into the root, but the negative sign doesn't. Be careful of that because you don't want to do a negative 6th root. You want to do a negative 6th root. Right? Distinct difference. So remember, always go up into that and then insert the negative sign in thereafter. But we have now our two different, our 70th percentile and our 30th percentile. And we just need to take the difference. So 323.8095 subtracted by the 230 number, and I get 93.1, which lines up with answer choice B. Okay, so I know that seemed like a long problem, but it was not a complicated one. It just took me a bit to explain and walk through the integration. Right, all in all, this problem would normally take you maybe 5 minutes, 7 minutes if your calculus is a little rusty. But it's an easy problem. If you have any questions or anything you think I should explain a little more clearly or need me to explain a little more clearly, throw it down in the comments. I'll answer it to the best of my abilities. If this video helped you out, hit the like button, subscribe, because that definitely helps me out. And if you want to see more questions like this, I have a playlist, SOA ExamP sample questions that, as of now, I'm filling as quick as I can. But that's pretty much it. Other than that, good luck.